Hello everyone, my name is Hassan, and welcome back to another Data in the Wild episode hosted by Data Meaning. Before we begin, don't forget to subscribe to the channel below and click the bell to turn on notifications to be the first to know every time we upload a new video. Today we're gonna talk about naive Bayes. It's a classification technique based on Bayes' theorem with an assumption of independency among predictors. In simple terms, a naive Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature. And this equation abides or explains the naive Bayes in a mathematical way. So what we're trying to examine is that the probability of having event A given the occurrence and that we are certain about having event B is equivalent to the probability of having event B given that A had occurred multiplied by probability of A divided by B. But this might sound too much mathematical and probabilistic. Let's get this into a real applied example. Imagine we're having two companies that have car production lines, and the first company manufactures 30 cars per day and the other one produces 20 cars per day. The probability of having a car from company 1 is 60% and from company 2 is 40%. And we can know from our internal system logs and the company logs that out of all the produced cars we can see 1% defectiveness in cars. So the probability of defect is 1%. And in order to be unbiased, we will assume that the probability of having a defect, the probability of having a car belongs to company 1 or company 2 is 50% given that those cars are defective. So probability of company 1 given that defect is 50% and the same applies for company 2. But when we are trying to predict an observation, the question we're trying to answer is, what is the probability that a car produced by company 2 is being defected? This is equivalent to this equation, the probability of defect given that this car belongs to company 2, which is equal to the probability of a car belonging to company 2 given that it's defected, which we have over here, the 50% one, multiplied by the probability of defective car, which is 1%, divided by the probability of having a car belongs to company 2, which is 40%. This is implicitly the Bayes theorem, which the naive Bayes algorithm is heavily dependent on it. But let's see this naive Bayes algorithm in Python implementation. So as usual, we're gonna import our main libraries, the NumPy, Matplotlib, and Pandas, and use the social network ads dataset. We're gonna check for the data if it's uploaded over here. I'm gonna just add it to this directory. Okay, so this social network ads file includes the age of customers and their estimated salary, with the dependent variable of purchasing, whether they did a purchase or not. So we're gonna load them into this Python, load the dataset into this variable and get the X and the Y, the independent variables and the Y variables value. And then we're gonna do the train test split using model selection from sklearn with the 25% for testing and 75% for training. And obviously this dataset needs to be scaled because we're working with different numerical ranges for ages and estimated salary. So we're gonna also import the sklearn preprocessing, the standard scalar one, and apply the fit transform function on the xtrain and the xtest. So now we can see it, they are sharing the same numerical scale. And we're gonna import also from sklearn the naive Bayes, the Gaussian naive Bayes classifier and fit the X train and the Y train one and try to predict a new result over here. So this one is like applying or checking for a customer of age 30 with a estimated salary of 87k, and the model is predicting it as a non-purchasing customer. We're gonna do the predictions over all the testing data set, and now we're gonna run the confusion matrix we have to check our accuracy, which is 90% over here. And I have preloaded the visualization for the training and the testing dataset, so you can see it over here. Of course, for the training we're having more points compared to the testing dataset, and obviously it's showing like 90% with low green points shown in the red areas, and the opposite also. And this is it for today. Stay tuned for another videos in machine learning algorithms. If you have any questions or suggestions for future videos, please comment below. Don't forget to subscribe to know when future videos are posted. And thank you for watching.